What's going on, everybody? Thanks for tuning back in. Today we're going to be taking a look at adding collisions to our player and to the game itself. In the last video, we took a look at actually creating our player character, but right now when you walk around, you can see that all we can do is walk around and nothing else really happens. The most basic interaction between a player and its environment is going to be collisions. Today's video is going to cover creating colliders for our tile map, as well as creating boundaries that are outside of our tile map in specific cases where the tiling itself can't be used. So for example, if you have an entrance to a cave where the player can go to both spots on that cave entrance, you're going to want to manually create a boundary around it so that the player can't walk through it. And you'll see what I'm talking about later. Everything else should be able to be done inside of the tile maps, so we're going to take a look at how to do that today. As always, if you like this video series, you can like and subscribe, and if you're finding it really useful, you can support the channel by buying me a coffee. Okay guys, let's get into the video. So if you open up the player scene, you're going to see that we have a player with all of our nodes that we created last time. Some of them already have scripts, some of them don't. Today we're going to be creating a script for our collision raycast. So we're going to define how the character scans for collisions, and we're going to be doing that with the raycast. For simplicity, we're not going to be getting too much into collision layers and collision masks. We're going to try and keep everything on the same layer for now. If it's more useful in the future to do, let's say, items or something like that with a different layer, we'll do that. But we're just going to keep everything the same for now, for simplicity's sake. Go ahead and create your script, and you could drop it into your characters folder. I'm going to call this character collision raycast, because for now, everything we do is going to be shared between the player and NPCs. And if we need anything specific in the future, we can create a specific class for that, like we did with our player input. Go ahead and create your namespace like we've been doing, and then you can go ahead and drop your class inside of it. I'm going to keep the ready and the process function because I'm going to reuse them both. I'm going to start off by creating a new signal. It's going to be a public delegate void, and this one's going to be my collision event handler, and it's going to take one parameter that's a bool. This event is going to be fired off whether we have a collision or not. The character input, or rather the character movement, is going to be listening for this collision event handler, and there will be a variable on the character movement that will correspond to this. And basically this is going to tell it to either be true or false. If there is a collision, it'll be set to true and we won't be able to move. And if there's no collision, we can go ahead and move. Follow up your signal by creating an export category. You can call it whatever you want. I'm just going to call mine collision vars. You don't really need this if you don't want it. And then I'm going to go ahead and add two variables. A public character input, because I'm going to need to access the character's input. And then I'm going to add a public Godot object collider. The Godot object is what the base class is for any object that's returned from your collider, or rather I should say the collision input event, and you'll see what we're talking about when we get to the process function. Inside of your ready function, and go ahead and log something like loading character collision raycast or something like that. You could see that I actually wanted to put player, but I realized that this is actually for any character, so you could just do character for now. Eventually, if enough classes inherit this, you can change this to the get type function in order to actually get the class name. Inside of our process function, the first thing we're going to do is check our raycast's target position. So this is where the raycast is pointing to. So for our 2D game, basically what we want this to be pointing at is the middle of the next square. How we check that is we check to see if the target position is not equal to our character input's target position. We're going to set our target position equal to that. That way, whichever way we're facing, this will always get updated by this script on the collision raycast itself. This is why it's nice to break everything up into separate files instead of having one giant file, as you can keep track of anything specific to whatever that file's function is. Next, what we're going to do is we're going to check to see if we are colliding with something, what to do. And how we check that is we basically call if and then the is colliding function provided by our raycast 2D. And inside of it, you can make your collider variable equal to get collider. And this will return the Godot object that is being hit by your raycast 2D. Now, obviously the reason it's a Godot object right now is because the game doesn't know what it's going to hit, so it needs to use the common base class in order for you to grab your definition from it. So how we're going to find out what we're actually hitting is we're going to create a new string, and we're going to make that equal to the collider.getType as a function, and then its name. That will return the actual class name of whatever we're hitting. If whatever you're hitting doesn't have a custom script on it, it's just going to return that. So for example, if you hit a node 2D that has a collider on it, it should just return that. But if you hit something like a character body 2D with a script and that script's name is player, it's going to actually return that player inside the name. So what we're going to do is we're going to create a switch case on that collider type. Since we don't have any crazy interactive collisions yet, we only need one collision, and that's just to see if we're actually hitting something for now. And that's just going to be the default case. So all you have to do is create a default case for now, and we'll fill this out later. Inside of the default case, you can emit a signal like we did in the last video, and you could do your signal name.collision and set that equal to true. Once you're finished with the switch case, you can create an else block to say that if we aren't colliding with anything, we're going to emit the signal name.collision with the value of false. That way, the character movement knows that in this particular moment, we're good to go. Now it's time to move on to our character movement script and add our collision modifications. So we only have to do a few things here. Inside of our nodes export category, I'm going to throw up our character collision raycast. And I'm going to also add one more variable to our movement, and that's going to be a bool to say that collision detected. And for now, I'm going to set that equal to false. Inside of our ready function, we're going to hook up our collision raycast's collision event handler to our collision detected variable. You can create a function to change this for you, or you can just do it inline like I'm about to show you. Go ahead and set your character collision raycast dot collision signal. You can do a plus equals, point to the value, and this is going to be kind of like a JavaScript function here, the syntax, and you can just have to point that to collision detected equals value. That way, whatever the signal is sending into the value is being set. Underneath your isMoving function, we can go ahead and create an isColliding function, and this will be a bool as well, and this just can return your collision detected bool. And then finally, right underneath in the start walking function, you can modify the if block, add an and just put if we're not isColliding. So this will allow us to walk if we're not moving or if we're not colliding. If the collision is set to true, now you won't be able to move. Let's go back to the Godot editor, and inside of your collision raycast, inside in the inspector, once you rebuild the project, you can assign the character input. And then similarly inside of the movement script, you can go ahead and assign the collision raycast. Now, once you do that, you could just fire up the game one more time just to make sure everything's still working and you're not missing any references, and you can still move around. But the collisions aren't going to work just yet. And that's because we actually have to add colliders to our tile maps and add any boundaries using static body 2Ds that you need inside of your level. So let's go ahead and take a look at how we're going to do that. Go ahead and click on one of your tile map layers. I'm going to click on ground. And if you take a look around and you go to the actual tile set on the right-hand side, you'll see above your terrain set something called physics layers. Go ahead and expand that and add one. Once you do that, you should have the ability now to actually add some colliders into your tiles. So let's go to the buildings tile set and play around a little bit here. If you go to the paint tab and then select a property from the drop-down menu and you go to your physics layer, you're going to see that a little screen pops up here with your collider. So I'm not going to get in depth too much about how the colliders work, but basically what we're going to be doing is we're going to be selecting every tile that we want the player to have a collision with. So for the buildings, what I like to do is have a collision for everything except for the door. And then I like to leave the top layer without a collider and increase the Z index so that it appears that the player is walking behind it to actually give you like a depth perception feel to the 2D game. So I'm going to go through and I'm going to add some colliders to all of the buildings here. I'm going to leave the top layer blank and you'll see what I'm talking about once I'm done. So if I test this really quick, you can see that if I walk into this building, look at that. I can't actually walk through it anymore and the collider's working. And if I walk over to the building over here that I left the top panels clear, you can see that I'm walking on top of them, but when I change the Z index for them, then it'll appear that I'm walking behind it. So let's fix that really fast. So I'm going to go and make sure that all of the top rows of my buildings here are all clear. And then if I go back to the select the property, I'm going to choose the Z index and I'm going to change the Z value to 10 because the player usually sits on 0. And we can change that later, but for now, we'll just set the top layer of these buildings to a Z index of 10. And then we'll run the game again and see if we show up behind the buildings. So let's walk behind the building and look at that. It looks like the player is actually being covered up by the building. I'm just going to walk around the map and make sure all the buildings are working properly, and then we can move on to the next step. So the next thing I'm going to do is I'm going to go to my tile set, and I'm going to go to my environment tile set, and I'm going to start adding colliders to all of the things that I don't want the player to be able to walk through. So things like the logs and the tree stump and things like that. In this specific tile map, I'm going to do the bottoms of all the trees, but I'm going to leave the top layer of any tree that's bigger than one tile. I'm going to leave those blank because I'm going to want to do the same thing to the trees that we did to the buildings, and that's leave the top layer with a higher Z index so it looks like the player is walking behind it. I'm going to do something similar with the border trees, but for this tile map layer, I'm going to be blocking all of the bottoms of the tree. So for example, a three-tier tree, the first two layers are going to be blocked. For the smaller two-tier trees, just the bottom layer is going to be blocked, so it makes it look like we can walk behind them. I'm also going to go through and I'm going to add collisions to all of like the mounds, all the ridges, and I'm going to try and block everything off. I'm going to do the cave entrances as well, so the forward-facing ones will be easy, but the ones on the side, if you can see, are only 2 tiles tall, and those are the only 2 tiles, so I'm going to have to do boundaries around those, but everything else I'm going to try and block off right now. Don't forget to do things like the fences, signs, anything you can think of. I'm going to speed through this, and then we'll meet back up in a second. So I've pretty much got everything inside my tile map that I want blocked. Now I got to do something for my border trees. So the border trees, if you remember, are treated like one giant tile. So when you actually initially try and put a collider on it, it's only going to do the small bottom corner that you set as the origin. In order to fix that, what you're going to have to do is actually expand the collider to cover the whole tree. And you can do that by enabling something called grid snap with this little button right here. And when you do that, you can calculate where you actually have to move the collider to. You can set the grid snap size, and if you set it to 1, it'll just make it 16 by 16, so that might make it easy for you. Next, I'm going to go back to my actual environment tile map, and I'm going to throw a tree in the middle of the map here so you can see the interaction with the colliders. And I'm going to do a big one and a couple small ones here. So let's run the scene and see what happens. And you can see that the collisions work with the fences and the buildings and everything that we've set. And the collisions with the trees are working, but you can see we're still on top of these ones. So let's go ahead and change the Z index on these trees as well. And once we're done changing those indexes back to 10, then we can go ahead and run the scene again and see if we appear behind the tree. And when we run the scene again, you can see that we do appear behind those trees. And let's walk over to the cave and see how this interaction works. So if I go into the main cave entrance here, you can see that everything works just fine. But if I actually walk up to the one on the side, we run into the problem we mentioned earlier, and that's there is nothing blocking this because the tile maps behind the cave entrance don't actually have colliders on them. So the other way around this is to actually create static bodies on the map itself. So what I'm going to do is I'm going to add a node 2D onto my level, and I'm going to call it boundaries. Underneath it, I'm going to add a static body 2D. And then underneath the static body 2D, I'm going to add a collision shape 2D, and I'm going to make that a rectangle. And all I'm going to do is just going to take the 2 tiles behind the cave entrance and move my static body 2D there, or my collision shape, I should say, and block the back of the cave entrance. Once you do that, I'm going to move the player actually over right in front of the cave just to test it really fast. And I'm going to hit play and see if this blocks me. And you can see I can't walk through the cave anymore, and the tiles above and below already have colliders on them, so now this entrance is closed off. So now let's go take a look at the border tree. So if I walk down, you can see that I can't walk any farther than the top of the tree, and I don't really like this look. I kind of want to walk behind them as well. So even though they're one big tile, we can actually play around with this and get this to work just like this tree in the middle of the map here. And how we're going to do that is we're going to go back to our tile set. And we're going to go ahead and take a look at our grid snap on our big border trees. I'm going to set that grid snap to 1. And then you'll see it just gives me the 2x3 tile layout that the other trees have. And I'm going to block the first 2 rows, but leave the top one open. Now, if I try and walk behind this tree, I'm still going to appear on top of it because the entire thing is set to 0. So I'm going to change the Z index of the border tree to be 10 as well. So we just have to make sure that it still looks okay because the whole thing is set to that. So if you tried to walk in front of the tree on the bottom of it, you might appear like you're actually behind it. It might look a little weird. So we're going to test that out. And you can see when we're walking around, we're actually appearing behind these border trees. So this looks a lot better in my opinion. And I'm going to walk over to the entrance of the level here. And it actually looks okay because it's just the shadow appearing over our player character with the character's expanded height. So I think this is acceptable. So while I was actually creating this video, I discovered a little glitch. And it's a glitch that happens because of the way all of our components are separated and the way we're calling signals between the collision raycast and our quick inputs where we're able to turn or start walking. The problem is that if you start walking in one direction and quickly turn, you actually can clip through and skip this whole collision system with the raycast. And that's because the raycast isn't updating fast enough. And your game thinks that you actually want to start walking in the direction you're facing before it can scan to see if there's a collider or not. So while for some grid system games like this, the collision raycast will be fine, because of the way we like to smash our inputs basically, I'm going to actually change the way this works a little bit to make it a little bit more robust. So let's open up our character movement script, and at the top you can get rid of a couple variables here. We don't need the collision raycast anymore, and I think we can get rid of the collided variable too. I don't think we're going to use that. And we're going to create a new function, and we're going to call it isTargetOccupied. That's going to return a bool. So it's only going to return true or false for us. And what we're going to do is we're going to pass in a vector2, and that's going to be the target position from where you want to walk to. And inside of it, we're going to make a new var, call it space state, and that's going to be equal to the built-in function getViewport, and then you're going to do the function getWorld2D on top of that and get the direct space state property. This is going to give us the information we need about the grid inside of our game. Next, what we want to do is we want to adjust the target position a little bit because we want to scan the middle of the squares around us, not the corner edges. And that's because sometimes the corner edges are going to collide incorrectly, especially if a collider is touching the edge on both sides. We want to hit the middle of each tile because we know exactly what's going to be in the middle of that square. Our player character's coordinates when they're moving around is actually the top left corner of the player, and that's usually what we judge everything from. So using the middle of the square will fix any of these issues. Next, we're going to create a query. It's going to be a physics point query parameters 2D. What this means is we're going to pass in some information about a 2D area we want to get some physics information about, aka our collisions, and we're going to run a function using this query. So inside of it, you're going to pass in the position, which is going to be our adjusted target position. The collision mask is the layer you want to interact with. In our case is 1. And there's another option we could throw on here called collide with areas. We don't have any area 2Ds made yet, but when we do, we're going to want this set to true. Our result is going to be spacestate.intersect point, and then you're going to pass in your query. You can pass in a limited amount of collisions you want in each square if you have overlapping colliders, but the default is 32, and you're never going to have more than 2 or 3, so you can just leave this blank. Next, we're going to check to see if our result.count is greater than 0. So if this returns an array greater than 0, we know we have at least one collision. And past this block, we're going to return false because if there's no results, there's no collision. And then inside, we're going to check each collision. So we're going to make a for each loop, and we're going to check for each var collision in our result. And then inside of it, you can grab the collider, kind of like we were doing with the raycast, by grabbing the collision dictionary using the collider key. But we're going to cast it twice, once with Godot object and once with node, because the collision collider's default type is variant. So you have to cast it a couple times to get the desired result. Once you cast it with node, it'll give you the actual type that it is, like a tilemap layer. Then, similarly to our collision raycast, you're going to check the collider type, and that's going to be equal to collider.getType.name. And then you're going to do a switch case on the collider type. The default is going to return true. So anything not in our switch case that we don't know about is going to be a collision. And then in our case, we know that everything around us for now is from the tilemap layer. So you can make a case for that and have that return true as well. When this collides with area 2Ds that you want to enter, like a scene transition, we're going to have it return false, but we're not going to worry about that for now. Next, what I'm going to do is I'm going to change the is colliding in my start walking function to is target occupied with the exclamation mark in front because we want to negate it. And we're going to pass in the target position. So I'm going to copy that out of, or I'm going to cut that out of, sorry, the if block and put that in front. And finally, I'm going to go to my player roam state and I'm going to add my character movement to my player roam state because I do want to disable my input if we're moving, just so I don't get any weird results with this new collision system. So add the character movement to your state vars, and then inside of get input, you're just going to check to see that if our character movement is moving function is true, just return and don't take in any input. Now inside of my editor, I'm going to add my character movement to my roam state. And now you can see that when I'm walking around, everything seems to be colliding properly. I'm going to get rid of this animation logging statement too, just because it's flooding my console. And now when I go back, you can see when I'm walking around, everything's colliding. I'm trying to do my glitch trick into the wall. It's not working anymore. So I think we've solved it with this new method. Finally, if you want to log to see what collider you're hitting, go back to that for each statement and just log the collider. And let's just run it one more time to see what that looks like. And you can see that we're hitting the tile map layer. So I think this is a better way to handle the collisions since the raycast is somewhat unreliable when you have to wait for it to update the position and emit a signal. This seems safer. So I think this is a good stopping point for this video. And I think in the next one, what we're going to take a look is our level transitions or our scene transitions. And that's going to clean up some more stuff for us. For example, maybe we'll go in and out outside of a house and maybe we'll make the Pokemon Center or something like that. And we'll also set some boundaries on the level so our camera doesn't view past and you don't see any of this gray. You only see the level. Okay, guys, thank you so much for tuning back in and hopefully we'll see you in part 5. As I said before, if you like this video, like, subscribe, and if you want to support the channel, you can buy me a coffee. Okay, guys, thank you so much.